Hello student, this is Dr. Savitha from Maharani Science College for Women. In the earlier video, we have learned what are aldehydes and ketones, and we have also learned its nomenclature. In this video, we'll be learning how to distinguish or how to differentiate an aldehyde and ketone. There are various methods by which you can differentiate an aldehyde and ketone. In this video, we'll be learning by the oxidation method. So basically the first question arises is why do aldehydes and ketone behave differently? So we know the aldehyde have this functional group where we have a carbonyl group where a carbon is double bonded with an oxygen and the other two valencies are satisfied with one of the hydrogen atom and another with an alkyl group in the case of an aldehyde. So, a carbonyl group in an aldehyde is associated with an hydrogen atom. So, we have an hydrogen atom attached to C double bond oxygen. When we look at the ketone, the same carbonyl group is also present in a ketone, but the other two valencies are satisfied by an alkyl or aride group. We do not have any hydrogen atom associated with the carbon double bonded with the oxygen, that is the carbonyl group. So a hydrogen atom is there in an aldehyde and no hydrogen atom is present in a ketone. So there are different methods as I already said, and in this video we'll be learning the oxidation method by which we are going to differentiate an aldehyde and a ketone, and the test that we are going to look in are the tolerance test, failing test or the Bendit's test. Coming to the oxidation of aldehydes and ketone. So, aldehydes and ketone can be oxidized by using various oxidizing agents, and a few examples for the oxidizing agents are acidified dichromate or acidified KMnO4 or acidified chromic acid can be used as an oxidizing agent for the oxidation of aldehydes and ketone. So, when we take the oxidation, aldehyde readily undergo oxidation under mild condition and get converted into the corresponding carboxylic acid. For example, when we take an aldehyde, upon oxidation, we get the corresponding carboxylic acid. Generally, ketones are highly resistant to oxidation. So, a mild oxidizing agent cannot oxidize a ketone. A strong oxidizing agent under drastic condition will only make the ketones to undergo oxidation. So, let us look why the ketones are resistant to oxidation. So, this is one of the example for a ketone, 2-butanol. So here this is your carbonyl group which is flanked on either side by an alkyl, a methyl and a ethyl group. So there is no CH bond or hydrogen atom is not associated with the carbonyl group and hence it cannot be oxidized under the normal condition and hence I say no reaction. Let us look in detail about the oxidation of aldehyde. So, chromic acid in aqueous acid, that is chromic acid, oxidizes the aldehydes to carboxylic acid. Similarly, various oxidizing agent, the tolerance reagent, can be used to oxidize the aldehyde. So, when I take hexanol and aldehyde, upon oxidation, and 0 degrees Celsius using the chromic acid and acetone as a solvent, we get the corresponding acid, hexanoic acid. The same is also true with an aromatic aldehyde. When I take benzaldehyde, upon oxidation, I get the corresponding acid, that is the benzoic acid. And a very important note in the case of aldehydes are, as I said, they are easily oxidized to carboxylic acid. And the important thing that has to be remembered in this is the carboxylic acid which are produced during the oxidation of an aldehyde contain the same number of carbon atom, and the oxidizing agent can be anything, a dichromate in acidic condition or acidified KMnO4. So the important thing is, if I have one carbon atom in my aldehyde, upon oxidation I get a carboxylic acid with the same number of carbon atom. So when a formaldehyde undergo oxidation, I get the corresponding formic acid. The same is also true with the acetaldehyde. Upon oxidation, I get a acid, carboxylic acid having the same number of carbon atom. So in the acetaldehyde had two carbon atom. In the corresponding acid, I also we have the same number of carbon atom, which has to be remembered in the oxidation of aldehydes. So this another example is benzaldehyde. Upon oxidation, I get benzoic acid. So next we look at the oxidation of ketone. As I said, ketone do not undergo oxidation easily, and on vigorous condition, a strong oxidizing agent, and upon heating, oxidation of ketone occurs to give the acid. But the important thing here to remember is the corresponding acid will have lesser number of carbon atom. So this is an important feature of the oxidation of ketone. So when we oxidize a ketone with on the drastic, that is the extreme condition, I get a carboxylic acid which contain less number of carbon atom. For example, in this ketone, we have 1, 2, 3, 4, a four-membered parent. Upon oxidation, I get either I get a three-member or I get a two molecules of two-member, or a carbon monoxide or carbon dioxide if a methyl ketone is there. So another example for the oxidation of ketone is propanol. Upon oxidation, I don't get a three-member carboxylic acid, but I get a two-member, that is the ethanoic acid, and hence the oxidation of a ketone result in the formation of a carboxylic acid with less number of carbon atom, and generally the cleavage around the ketone occurs in such a way that one of the hydrocarbon part is oxidized, which contain the carbonyl oxygen, and other hydrocarbon is oxidized to give you the carbon dioxide and water. Now, as we all know, in the ketone, we can have an unsymmetrical or a symmetrical. What do I mean by an unsymmetrical is the alkyl group that are associated with the carbonyl oxygen may be same, then I call it to be a symmetrical. If they are different, then I call it to be an unsymmetrical ketone. So let us look at the oxidation of an unsymmetrical ketone, and here the characteristic feature is whenever an oxidation of an unsymmetrical ketone occurs, the C double bond O or carbonyl oxygen bond remains with the smaller chain. So let us take an example of an unsymmetrical ketone, buta-2-ol. So this is the carbonyl. Here on one side I have a methyl and other side I have a ethyl, and hence it is an unsymmetrical ketone. So when I do the oxidation of such a ketone, the cleavage can occur either between the carbon atoms 1 and 2 or between the atoms number 2 and 3. So let us look what happens when a cleavage involves the carbon atom 1 and 2. So when I break the bond between 1 and 2, I'll get this portion on one side, another portion on this side. So in this case, the C double bond O group with a longer chain is obtained, which is not preferred. So the cleavage involving 1 and 2 generally does not occur. Let us look the other part of the cleavage, that is the cleavage involving the carbon atom 2 and 3. In this case, the carbonyl oxygen is attached to a smaller alkyl group, and this is most favorable for the oxidation of an unsymmetrical ketone, and this results the major products. So when the cleavage occurs between the carbon atom 2 and 3, we get this as the product. So here also I get contain two carbon atom. This also contain the two carbon atom, and we get the two molecules of acetic acid. So I can represent the oxidation of an unsymmetrical ketone as follows. So here the cleavage is between the second and the third, resulting in the formation of two molecules of acetic acid which has less number of carbon atom compared to the parent ketone. Next, coming to the symmetrical ketone. So as I said, symmetrical ketone, the two alkyl groups flanking the carbonyl carbon will be the same. So here also have a ethyl, here also I have ether, and hence this is an example for a symmetrical ketone. And in case of symmetrical ketone, only one type of cleavage occurs, and I get a mixture of two acid. For example, when I take a penta-3-one, it does not matter when I either cleave between 1 and 2 or 2 and 3. I get the product as follows, that is, one is acetic acid and another is propionic acid. Hence the product form will be 3-member and a 2-member, and the whole reaction can be represented as follows. Let us look the various tests that we are used for the distinguishing the aldehydes and the ketone. And the first test I am going to is tolerance test. It says that it contains ammonical silver nitrate. It oxidizes the aldehydes but not ketone. So whenever we use a tolerance reagent, aldehydes we get a silver mirror, and this is the equation where an aldehyde in tolerance reagent we get the silver mirror and the corresponding carboxylic acid containing the same number of carbon atom. So this tells in detail the tolerance reagent is ammoniacal silver nitrate solution. You get a gray precipitate or a silver mirror is formed where the aldehydes are oxidized to corresponding acid, and silver intolerance reagent is reduced from +1 oxidation to its elemental state. So this is the test and these are the reaction. Now we'll go to the other oxidation method where I can use the Fehling's test and the Bendix. Both of them contains the copper ion, one in with the tartrate in Fehling's solution and other with the sodium citrate in sodium carbonate. Coming to the Fehling's test and the Bendix test, here the cupric ions will be converted into cuprous oxide, which I get a red color precipitate only with an aldehyde and not with a ketone, and hence this test can be used to differentiate an aldehyde and a ketone. So coming to the Fehling's test, it contains a complex compound of cupric, and when aldehyde is treated with Fehling's solution, this cupric is reduced to cuprous and the aldehyde is reduced to acid, and because of this you get a red characteristic feature for color with an aldehyde which confirm the presence of aldehydic group. And the last thing answer is why do ketone does not give tolerance test and valence. So we know aldehydes have an hydrogen atom. Presence of the hydrogen atom makes the aldehydes to get easily oxidized and get the corresponding color, either silver mirror or a red precipitate with Ag plus or Cu plus 2. But in the ketone, we do not have an hydrogen, and hence the cleavage occurs resulting in the formation of lesser acid, and we don't get any red precipitate or a silver mirror in the case of ketone since it involves the oxidation of CC bond, and hence it can be only oxidized by strong oxidizing agent. Thank you.